Hello guys, good to see you back. Once again I am back with a new project related Python OpenCV. And today in this project we are going to perform object tracking using color segmentation. Yes, we are going to track object using color based segmentation. Object tracking is a computer vision technique for locating position of an object on a image or video. Remember, recognizing the object and tracking the object are two different things. In object tracking, you can track any moving object, but in object detection, you can identify the object. So these are two total different things. There are many type of object tracking method in OpenCV, such as color segmentation based, frame differencing based, and feature matching based. And in this tutorial, we are going to perform color segmentation based object tracking. And to perform the effective color tracking, we are going to convert BGR color into HSV color. And as you know, HSV stands for hue, saturation and value. Hue stands for color, value stands for amount of color, and saturation stands for gray amount of color. So without talking too much, let me show you an example what we are going to create in this tutorial. Now you can see it successfully track our object. It can track our blue color bottle cap. In our frame window, you can see the original footage. And in our mask window, here you can see the bitwise operator footage. Here white represent the bottle cap and black color represent unselected area. But in our third window RES, here you can see the actual color object. Here you can see the exact bottle cap. Without this bottle cap, you can't see anything here because it tracks only this color segmentation from this window. So this is what we are going to create in this project. So let's jump into the computer screen and start the project. Before we start our coding, let me introduce you something. This project is part of my Mastering Python OpenCV course on Udemy, and as you can see, it is the new, fresh and bestseller course on Udemy. Till today, it comes with 11.5 hour plus content on it. And it comes with multiple real-world projects. So if you are interested to learn Python OpenCV from the very beginning, I will provide the link in my description. Just check this course on Udemy and you will understand why it has become bestseller. So let's back to the code. So as you can see, finally we are in my Visual Studio code editor and I already created a Python file main.py. At first, I'm going to import our important library. So I'm going to type import and I'm going to import CV2. Then I'm going to import NumPy. Yes, NumPy is important to create this kind of project. So I'm going to type import NumPy as np. Next we need to import pyplot from the matplotlib. So here I'm going to type import matplotlib dot pyplot as plt. Here we are going to perform object tracking based on the object color. Object tracking and object recognizing is totally different things. In object tracking, we can track any moving object. But in object recognizing, we need to recognize the particular object. And as I told you earlier, there are many methods that we can use for object track, such as color segmentation, frame differencing, feature matching, machine learning based, etc. But as you know, we are going to perform color segmentation based object tracking. Now let's start the practical. At first, we need to create a video object to capture the frame. To capture the frame, we are going to use our webcam. So here I'm going to type a variable name cap assign with, and here we need to use a method called video capture. cv2.video capture, this one. Then inside the round braces, here we need to pass the source 0. Then after that, I'm going to define an empty function. Why we need empty function? Because we are going to create track bar using it, and to create this track bar we need to return empty function which is going to return nothing. So here I'm going to type def and our function name is nothing. Inside the round braces I'm going to pass a normal parameter called x, and inside the function, here I'm going to type pass. Basically it's going to return nothing. Then using this empty function, we are going to create track bar. But before I create track bar, we need to define the track bar name. So here I'm going to type cv2 dot named window. Here I'm going to use a method called named window, and we need to provide a name for this window, for our taskbar window, and I'm going to type tracking. Now here I'm going to create total 6 track bars, because we need to grab upper hue saturation value and we also need to grab lower hue saturation value. So let's create our first track bar. So here I'm going to type cv2 dot create track bar. This function. Then inside the round braces, at first we need to create track bar for lower bound value for hue. So here I'm going to use the short form lower hue, LH. After create the track bar name, we need to pass the window name, in which window we want to show the track bar. So inside the double quotes, I'm going to pass this window name, tracking. Next, we need to pass a value. Here we need to pass the lower value, which is called 0. Then we need to pass the higher value, and for higher value I am going to pass 255. At last we need to pass a function. This function going to return nothing, so I'm going to use this function nothing. Just we need to copy the function name and put it here. I'm not going to set any default value to our track bar, because we are going to set it manually. Then I'm going to duplicate this line, and this time I'm going to change the name of this track bar, which is LS. LS stands for lower saturation. Then I duplicate it again, and this time I'm going to name it LV, lower value. So this 3 track bar stands for lower bound value. Now we need to pass upper bound value. So I'm going to duplicate the whole 3 line. So our last 3 track bar is for higher value. So higher hue, and second one is higher saturation, and last one is higher value. And now we need to run a infinite loop to continuously process the video frame. For that we are going to use while loop. So here I'm going to type while true. Then inside this while loop I'm going to use read method. Read method capture each frame from the webcam. And to store the capture value and the boolean value, I'm going to declare total 2 variables. First I'm going to declare b, which is going to store the boolean value. Then I'm going to declare another value called frame. Frame equal to cap dot read method. Then after read all the color frame, we need to convert color frame into HSV. As you know, by default OpenCV use BGR color format. So we need to convert it into HSV color format. So I'm going to declare a variable HSV equal to cv2 dot cvt color. Then inside the round braces I'm going to pass the frame. So at first we need to pass the image source. So I'm going to pass the frame variable, frame. Then I'm going to convert it cv2 dot color underscore, and I'm going to convert it BGR to HSV. So I'm going to search for BGR to HSV, this one. Next we need to get HSV value from these track bars. For that we need to declare different variables to store the track bar value. So for lower hue I'm going to type L underscore H equal to grab the data from this track bar we need to use a method called get track bar pause. So I'm going to type cv2 dot get track bar pause, this one. And then inside the round braces inside the double quotes, first we need to pass the track bar name, from which track bar I want to grab the value, which is LH. LH. Next, we need to define the window name, and our window name is tracking. So I'm going to use this window name, tracking. So I copy the window name and inside the double quotes, I'm going to paste it here. At the same way, we need to create 5 other variables to get the value from the track bar. So I duplicate this line. This time I'm going to extract value of ls. So here I'm going to type L underscore S, and also I'm going to change the track bar name ls. At the same way, I'm going to create all of it. This one is for LV, and I'm going to change the name LV. Then I duplicate this 3 line, and I'm going to make this one HH, H underscore H. This is for high hue value. Next one is for high saturation value, HS. And the last one is for HV. Also going to change the track bar name, which is HV. So these lines retrieve the current position of the HSV track bars, which represent the lower and upper bound of the HSV color range. We are going to use it for masking. And next we need to create lower and upper HSV bound array. To create those array, I'm going to declare a variable L underscore B. It stands for lower bound array. And to create this lower bound array, we are going to use numpy. np dot array, inside the round braces, here I'm going to pass all the lower bound value. L underscore H, comma, L underscore S, comma, and L underscore V. At the same way, we need to create upper bound value. So I duplicate this line, and I'm going to change the variable name UB. UB stands for upper bound value. So here also we need to change the variable's name. I'm going to make it HH. HH stands for higher value. HS. HS stands for higher saturation. Higher hue, higher saturation, and higher value. And next we need to create mask using lower bound value and upper bound value. And to create this mask, we are going to use in-range method. This is the most important part of this video. So at first I'm going to declare a variable called mask equal to cv2 dot in-range method. In range. Then inside the round braces, first we need to pass the source. And as source, I'm going to pass this variable HSV. So I'm going to type HSV. Then we need to pass the lower bound value. And as you can see, we store the lower bound value using this variable L underscore B, lower bound. L underscore B. Also, we need to pass the upper bound value. And we represent upper bound value using U underscore B. That's it. So here we create mask using in-range function. In-range function used to create mask based on color values in the HSV color space. At first we pass HSV color space. This is HSV color space image. We convert BGR image into HSV here. So I pass this variable. First we pass array of lower bound value, then we pass array of upper bound value. Now the cv2.inRange function convert these values into a binary image. And we store this binary image into mask variable. And as you know, binary image create with total 2 value, where 0 represent black and 255 represent white. Now this mask highlight the region in the frame that match the specified color range. Suppose you select blue color in your track bar, then it's going to show only the blue color portion in your window. And now we need to apply this mask with bitwise AND operator. Here I am not going to explain in depth how bitwise AND operator work. So to apply the mask on bitwise AND operator, I am going to declare a variable res. Res equal to, we need to use bitwise AND, so I am to type cv2 dot bitwise AND operator. Then inside the round braces, at first we need to pass the source, first source, which is frame, and as second source I'm going to pass another variable frame. So in our first value we pass the original frame, and in our second value also we pass the original frame, because since we are masking the original with itself. And now we need to pass the mask variable. So here I'm going to type mask equal to the mask. So this creates an output that shows only the part of original frame that match the specified color range. Basically it's going to isolate the object based on the color. And now I am going to display the video and the mask output, also the res variable. So here I am going to use IamShow method. So I am going to type cv2 dot IamShow. Then inside the round braces, first I am going to pass the window name, in which window I want to display the frame. So our window name is frame. Then I'm going to pass the variable frame. So basically this window going to show us the original footage, the colorful footage, BGR color footage. Then I'm going to show you the mask footage. So I duplicate this line and replace frame with mask. And at last I'm going to display this res variable, this footage. This is after intersect with bitwise AND operator. So here, so at first I'm going to change the window name res. Also I'm going to replace this variable mask with res, and I'm going to save this file. And now we need to set a if condition to break the loop using wait key method. So here I'm going to type a if condition if cv2 dot wait key, inside the round braces I'm going to wait for 25 millisecond and 0x ff equals to ord. Inside the round braces, if I press small q in our keyboard, then I want to break the loop. Break. So this is it. After that, we need to release the capture. Cap dot release method. This is going to release our video capture. Also, we need to destroy all the windows. cv2 dot destroy all windows. So we are done, but here I did a silly mistake. As you can see, it's an array, so we need to pass this value inside the square braces. So here I'm going to add square braces. And now I'm going to save this file again and I'm going to run this code. Now let's run the code in our terminal. After click run button, we need to wait for some time to start our webcam. So as you can see, here it open our window. Here we have total 4 windows. First one is for tracking bar, and second one is for original frame, and third one is for mask. It is for bitwise mask, and I'm going to place all the windows side by side that we can compare the result very easily. So as you can see, this is the single color bottle cap that I'm going to use to perform the object tracking. Here I use solid blue color variant bottle cap. You can use any solid color object. And I'm going to match this bottle cap color using our track bar. And now we need to play with this track bar to match the bottle cap color. We need to play with this 6 value. So at first I'm going to increase the high value, then I'm going to increase the high saturation value. We need to adjust these bars to get the perfect result. And as you notice, when I change the values, it reduces the noise and try to focus on our bottle cap. I am going to fast forward this process to get the perfect result. Now these coordinates nearly give me the perfect result. Now you can see it successfully track our object. It can track our blue color bottle cap. In our frame window you can see the original footage. And in our mask window, here you can see the bitwise operator footage. Here white represent the bottle cap and black color represent unselected area. But in our third window RES, here you can see the actual color object. Here you can see the exact bottle cap. Without this bottle cap you can't see anything here, because it tracks only this color segmentation from this window. Now let's kill the window and back to the program. So this is how we can perform object tracking based on color segmentation. So I hope now it's clear for you how we can create it. And following the nearly same process, we can create air canvas with it. We are going to learn about it in our upcoming tutorial, don't worry about it. So thanks for watching this video, stay tuned for our next tutorial.